my name is Kristine, and I come from the University of Copenhagen, where I, as a physicist, am doing a PhD within material science. My research is on superconductors and how we can learn new things about superconductors through neutron scattering. So specifically, I try and understand how magnetic fluctuations in certain types of superconductors behave, and see if those magnetic signals teach us anything about what makes a superconductor a superconductor. A superconductor is the literal meaning, has the literal word. It is super at conducting. So many are perhaps familiar with when you have, say, a phone charger, it can get hot. And that's because the electricity going through it, there is resistance in the material itself. But with a superconductor, it's super at conducting, hence there is no resistance whatsoever inside of the material. Usually we know that they repel each other because they both have negative charge. But actually, if the movement of the atoms are just right, they can actually pair up into and create like a pair which is known as Koopa pairs. And whenever that happens, it kind of creates a, should you say, free path for the electrons, where it doesn't cost any energy to then move around within the material itself. Then they are kind of free to go wherever they want. It's actually very widely used, especially within hospitals, where they're used in CT scanners to take pictures of cancer patients, of tumors. They are used within trying to make quantum computers in new quantum electronics. There is many applications already, and when we find superconductors that work at higher temperatures, then there will be even more applications. Day to day, I usually work at the University of Copenhagen, in the slightly northern part of Copenhagen. But also I like to, once a week, I go to ESS in Lund, because part of my work, not only working with superconductors, but also working with the instruments being developed here. So I go here once a week to talk to my supervisor and to work efficiently and have dedicated time just to look and do work with the instruments here. We create so much data that we actually need data to describe our data, which is known as metadata. And it's a way for us to know more about the parameters of our experiments. For instance, in our case, it's the experiments, but it could also be used in many other fields as well. So at ESS, we have the DMSC, so that's the Data Management and Software Center. And they help structure all of this in a way that allow scientists like me to have easy access to the information and be able to analyze my data in a correct and efficient way. Machine learning is essentially, in its essence, it's linear algebra that we know from math, and the way that we can then use we can use these mathematical methods within our computer to do a bunch of calculations. We can make comparisons, and from algebraic methods we can use to find features in our data in the settings that we have. And that's essentially how we can use machine learning in the future. I think actually ESS is the one major thing that is happening in the future in terms of neutron research. There will be the amount of neutrons will give so that ESS will give so much more clearer insight into the physics of materials. I think that's really, I went to go work for the place where I think that the biggest change is going to happen.